A very good morning, students. Today we will be continuing our lesson number 14, measurement and effects of heat. So students, we are going to study about calorimeter. Have you ever heard before this? What is calorimeter? So see students, till now we know if we have to measure temperature, we were using thermometer. But one arrangement is made in which obviously thermometer is there, but an special arrangement is there for measuring the heat content of an object. Whichever object we keep, we can be able to know the content of heat of that object. Okay? So students, don't get confused. In simple words, what is calorimeter? A calorimeter is used to measure the heat content of an object. And when we have to measure the temperature of the object, we were using thermometer. And when we have to measure the heat content of an object, we will use calorimeter. Okay students? Is it easy now to understand? With the help of a calorimeter, we can know how much of heat is absorbing by the object or how much heat is getting lost from the object. So students, have a look on the diagram. Normally what happens here is a thermos flask like thing. You have always seen a thermos flask. How is it? It looks like same. You can see a beaker like object which is having a heat resistant lid. Inside you can see outer vessel and inner vessel, and middle of both there is air cavity. Why air cavity is there? Because heat does not get exchanged. It works as an insulator. So air cavity here works as an insulator. So inside vessel is filled with water and thermometer, and stirrer is placed inside the inner vessel, and whatever object we want we can place inside it. So is it clear students? This is how the arrangement of calorimeter is done. So students, normally what happens whenever we place an object inside the calorimeter, the object will gain heat if the temperature of object is less than the water. Then it will gain heat, and either the temperature of the object is more than the inside water, then what it will do? It will lose its temper in order to maintain the temperature to the balance and equilibrium. Students, so what it means? In both the cases, balancing of temperature is necessary, and that is what the calorimeter is all about. Calorimeter does both the things. If the temperature of the object is more, then it will give its temperature to water, and if the temperature of water is more, it will give its temperature to the object. So students, now let's suppose the mass of the inner vessel in the calorimeter is denoted by mc. M stands for mass and C is the copper vessel which is there inside the calorimeter, and its initial temperature is denoted by Ti, and the mass of the water in the calorimeter is Mw. M is for mass and W denotes water. The temperature of water will also be Ti, initial temperature. Suppose we place an object of mass M0. M stands for mass and O is for the object, so mass of object, and temperature T0. T is for temperature and O for object in the calorimeter. If TO is higher than Ti, the object will give away heat to the calorimeter and water. Soon the temperature of all three will become the same. Now students, whatever object we have inside the calorimeter, Tf will be its final temperature. Ti will be its initial temperature. Qo is the total heat of the object, and total heat of calorimeter is denoted by Qc, and plus Qw is equals to the total heat of water, where Q stands for heat and W for water. So what will be the equation become now? Qo is equals to Qc plus Qw will be the total heat loss or gain from the object. Now students, we know that. We have learnt it before. Q is equals to M multiplied by delta T multiplied by C. Where students Q was heat. M is for mass. Delta T is the change in temperature, that is final minus initial temperature. And C will be equal to specific heat, because C is the symbol stands for specific heat. And if we consider for QO, what will happen? What will happen? QO is equals to MO multiplied by delta TO multiplied by CO. And here students, delta TO is equals to TO minus TF, which means temperature of object minus final temperature. So same how we can remove off QC, that is QC is equals to MC multiplied by delta C multiplied by CC, and delta TC is equals to TF minus TI, that is final temperature minus initial temperature. And students, last but not the least, we can remove also the heat of QW, that is of water. So QW is equals to MW multiplied by delta TW multiplied by CW, where delta TW is equals to again TF minus TI, which means final temperature minus initial temperature. Now see students, pay attention. Our first formula we had written as QO is equals to QC plus QW. Now substitute. In place of QO, we can write MO multiplied by delta TO multiplied by CO. Same how it equals to MC multiplied by delta TC multiplied by CC plus MW multiplied by delta TW into CW. And this will be the formula for calculating the amount of heat loss or heat gain by any object by calorimeter. So students, let's clear our concept more clear by solving numerical. Question 1. Suppose the masses of the calorimeter, the water in it and the hot object made up of copper which is put in the calorimeter are the same. The initial temperature of the calorimeter and water is 30 degrees Celsius and that of the hot object is 60 degrees Celsius. The specific heats of copper and water are 0.09 calorie per gram degree Celsius and 1 calorie per gram degree Celsius respectively. What will be the final temperature of water? So students, see the first line. Suppose the masses of the calorimeter are the same. They are saying as the mass of water, mass of object and a mass of calorimeter is the same. So we will write it as MW is equals to MO which is equals to MC which is equals to M. MW is mass for water, MO is mass for object, MC is mass for calorimeter. So we are denoting all three by the letter M. Now see the second line. The initial temperature of the calorimeter and water is 30 degrees Celsius and that of the hot object is 60 degrees Celsius. So Ti is given as 30 degrees Celsius and the temperature of object is given as 60 degrees Celsius. So TO is equals to 60 degree and Ti is equals to 30 degree. Okay students, now see the third line. The specific heat of copper and water are 0.09 calorie per gram degree Celsius and 1 calorie per gram degree Celsius respectively. So specific heat of copper is our object kept in the calorimeter. Not to get confused how copper came from here. So the object which we are saying is the copper object which is kept in the calorimeter. So specific heat of copper is Cc is equals to 0.09 calorie and for specific heat of water is 1 calorie. We know this. Now see the last line student. What we have to calculate? What will be the final temperature of water? So we have to calculate the final temperature which is as TF. TF is equals to question mark. So solution. First write all the given things. MW is equals to MO is equals to MC is equals to M. TI is 30 degrees Celsius. TO is equals to 60 degrees Celsius. And CC is equals to 0.09 calorie. So to find TF is equals to question mark. So formula, we know the formula, students. M multiplied by delta T multiplied by C is equals to M multiplied by delta T multiplied by C, which is equals to M multiplied by delta T multiplied by C. Now we have to write the values in the formula. First one was for object, second one for water, and third one for copper. So what it will become now? MO multiplied by delta TO multiplied by CO is equals to MW multiplied by TW multiplied by CW multiplied by delta C multiplied by CC. Okay, students? So students, we know M, that is mass, was same for all three. So we can eliminate M, that is we can cancel out M because it is common in all the sides. So we will cancel out M. So our next step is cancellation of M. Now we will get the equation as we will substitute delta TO value, remaining values. We have cancelled out all M values. So next equation will become as 60 minus TF multiplied by 0.09 is equals to TF minus 30 multiplied by 1 is equals to TF minus 30 multiplied by 0.09. Now in place of TW, TF minus 30 comes. So TF minus 30 comes from TF means final temperature and 30 is given as initial temperature. Okay. Now we will take TF minus 30 as common on RHS side. So it will become as 60 minus TF multiplied by 0.09 is equals to TF minus 30 multiplied by 1.09. TF minus 30 is twice on RHS side. So we will write as 1 and 1 multiplied by 0.09 will give you as 1.09. Now 60 minus TF into 0.09, we will multiply the entire bracket by 0.09 on left hand side and on right hand side we will multiply TF minus 30, that is the entire bracket, by 1.09. So by multiplying all the terms in the bracket, our equation will become as 60 multiplied by 0.09 minus TF multiplied by 0.09 is equals to TF multiplied by 1.09 minus 30 multiplied by 1.09. Students, here are all mathematical calculation. Now our next equation, 60 multiplied by 0.09 plus 30 multiplied by 1.09 is equals to TF multiplied by 1.09 plus TF multiplied by 0.09. Now you will be thinking how it came. We are writing all the coefficient term one side and all the variable term one side. You can see on LHS side there is no variable term. So we have taken all the coefficient term one side and all the variable term one side. Now multiplying 60 multiplied by 0.09 gives you 5.4 plus, the sign is plus, so 30 multiplied by 1.09 gives you 32.7, which will be equal to TF. TF we will write as common because it is twice, TF into bracket 1.09 plus 0.09. It will give you as 5.4 plus 32.7 is 38.1, which is equals to TF 1.18. Now 38.1 divided by 1.18 is equals to TF. The value of 1.18 was in multiplication on RHS side. So when it will come to LHS side, it will change its sign into division. So after dividing it, you will get the value as 32.288 degree Celsius. So 88 it has come. So we will take the approximate value. So it will become as 29. So 32.29 degrees Celsius is our final temperature of water. So students, we have calculated the answer. We have solved the numerical. It was to find final temperature of water. So we got the value as the final temperature of water is 32.29 degree Celsius. Now students, we are going to take the new concept, that is expansion. Before starting with these, why expansion will happen? What is the reason for expansion? Have you ever think about it? So students, it is due to effect of heat. So effects of heat is of two types. Expansion, that means size increases. Second one, contraction, that means size decreases. So students, I will give you an example for expansion. Suppose you are having an iron rod and we are going to heat it. Listen to it carefully student. We are having an iron rod and we are going to heat it. After heating, what will happen? The rod melts. It means it got expanded. That means size got increased, shape also got changed. So, when heat is given to any substance, its temperature increases and it expands. Its expansion depends on the increase in its temperature. Okay, say my student, I am taking a frame and fill that frame with the melted iron. Frame means a box or a content which we are going to fill it with the iron which we have melted. We will leave it for some times. What will happen student? The iron liquid will take the same shape of that frame, which means it get contracted because heat is reduced. See students, listen to it carefully not to get confused. Whenever we heat an object or supplies heat to an object, what happens? It got expands, and whenever we make an object cold or we make it to come on room temperature, what happens? It contracts. So on heating it gets expands, on cooling it gets contract. Now students, let's see expansion in detail. Expansion in case of solid. Expansion in solid are of three types: linear expansion, areal expansion and volumetric expansion. The term in itself indicates what it means. We know what is linear, what is areal and what is volumetric. We will see one by one. What do you mean by linear expansion? In simple, it means change in length. Linearly means in a line. So, change in length is known as linear expansion. Suppose student, we have a rod and its length is L1 at initial stage. Not giving any heat, not changing the temperature, we have the length as L1. Now we will supply heat to that rod. So what will happen? After supplying heat, it will expand. Expansion takes place. Now when we talk about linear expansion, what happens? Length increases. Linear expansion means increase in length. So after heating the object, whatever is the change in the length, that much length we will be saying as L2. Before doing any change, before heating the object, we were saying the length as L1. And after the changes has taken place, expansion has been done, we will say the length as L2. So we got two terms, L1 and L2. And now temperature change also takes place. How? Before heating, the temperature was at room temperature. So let's name as T1, and after supplying heat to it, that will become as T2, and we will denote it as delta T, because we know delta T is change in temperature. So change in length is proportional. So what it means? Whatever change in length is there is because of what? Because of change in temperature. And what the changes is taking place? It is on rod. So change in length is proportional to original length and change in temperature. So we will write mathematically. So what we assumed before? Change in length was L2 minus L1. Understanding student? First length was L1. After expansion we got as L2. So L2 minus L1 will be change in temperature. So now change in length is proportional to original length. Original length is L1 and change in temperature. See, so we got the equation as L2 minus L1 is proportional to L1 multiplied by delta T. So by this equation we will derive formula. So students, whenever we see the proportionality sign, we have to remove it. So in order to remove the proportionality sign, we have to multiply by an constant. So now which constant we are going to take? We are going to take lambda as constant. So equation becomes L2 minus L1 is equals to lambda multiplied by L1 multiplied by delta T. Equation 1. Students, what is lambda over here? How it has come here? Here lambda is the constant of proportionality and it is called the coefficient of linear expansion of the solid substance. Now solving equation 1. L2 is equals to L1 multiplied by 1 plus lambda delta T. This we became as equation 2. This is one of the formula. And if we have to remove the value of lambda, we will derive the formula as, we will take lambda on LHS side and other terms on RHS side. So this way we can find out the value of lambda. So what the formula will become? Lambda is equals to L2 minus L1 divided by L1 multiplied by delta T. And here lambda is coefficient of linear expansion. So its value is fixed. It's always given in the question if a numerical comes on this concept. So students, we will solve a numerical based on this concept. Question. What will be the increase in length of a steel rod of length 0.5 meter when its temperature is increased by 60 degrees Celsius? The coefficient of linear expansion of steel is 0.000131 per degree Celsius. So, what is given, students? First given terms. Initial length of the rod is given. So, L1 is equals to 0.5 meters. Change in temperature is given as 60 degree Celsius. And lambda S. What is lambda S? It is the coefficient for steel. Coefficient for steel. It is, the value is given as 0.00013. Okay students, and what we have to find? We have to find increase in length. So we know the formula, students. What is the formula? Lambda is equals to L2 minus L1 upon L1 multiplied by delta T. So we have to find L2 minus L1 is equals to lambda multiplied by L1 multiplied by delta T. Students, we have to find the value of L2 minus L1, that is change in the length. So we will do corrections in the formula. So we will take LHS side on LHS side L2 minus L1 and all the other terms on RHS side. So what it will become now? L2 minus L1 is equals to 0.0013 multiplied by 0.5 multiplied by 60. Because lambda's value is given, L1 value is given and delta T value is also given. So after multiplying all the three terms, we will get the answer as 0.039 centimeter. And this was the answer. What was the answer for? It was for L2 minus L1. And what is L2 minus L1? It is increase in length. So students, moving to the next expansion of solid, which is areal expansion. Students, it is similar to linear expansion. In linear expansion, it means the increase in length. And in areal expansion, the entire area increases. Whatever the object having its area, the entire area will increase on heating. So this is known as areal expansion of solid. So similar to linear expansion, the area of a sheet of a solid material also increases on heating. This is called the areal expansion of solid. This is given by the following formula. The formula for this is A2 is equals to A1 multiplied by 1 plus sigma multiplied by delta T. Here students, delta T is the change in temperature and A1 and A2 are the initial and final areas of the sheet, and sigma is the coefficient of areal expansion of the solid. In last linear expansion, lambda was the coefficient of linear expansion of solid. Here only a slight change. Sigma is the coefficient of areal expansion of the solid. Now students, Moving to the next expansion of solid, it was volumetric expansion. Now students, similar to linear expansion, areal expansion, in linear expansion increase of length, in linear expansion increase of length, in areal expansion increase of area. So in volumetric expansion, increase of entire volume of the object on giving heat is known as volumetric expansion of solid. Similar to a sheet, a three-dimensional piece of solid expands on all sides when heated and its volume increases. This is called volumetric expansion. This is given by the following formula. Now, formula for volumetric expansion. V2 is equals to V1 multiplied by 1 plus beta delta T. Here students, delta T is change in temperature and V1 and V2 are the initial and final volume of the solid. V is denoted for volumetric expansion, like in the last slide A was denoted for areal expansion. So V is denoted for volumetric expansion, and here beta is the volumetric expansion coefficient of the solid. Okay students, all the three expansions are very easy. It all will be clear to you while watching it again. Now student, here we will move to the next state of expansion. Next state means, now we have done for solid, now we will learn for liquid. Now what is expansion of liquid? We know students, liquid does not have a definite shape, but it has a definite volume. We know the difference between shape and volume. So student, what is expansion of liquid? A liquid does not have a definite shape, but it has a definite volume. So we can define a volumetric expansion coefficient for a liquid as follows. V2 is equals to V1 multiplied by 1 plus beta into delta T. So students, here delta T is the change in temperature and V1 and V2 are the initial and final volumes of the liquid. Now we will take V2 and V1 because your shape is not changing because it is a liquid. Volume, it has a definite volume. Shape changes, it does not have a definite shape, but it has a definite volume. So whatever heat will be given, volume will be changing. So we are taking here V. So V2 and V1 are the initial and final volumes of the liquid. Beta is the volumetric expansion coefficient of the liquid. Now moving to the next concept, that is expansion of gases. Now we will see the expansion of the next state in gas. So students, a gas does not even have a fixed volume. Gas expands on heating, but if the gas is kept in a closed box, its volume cannot increase, but its pressure increases. So making it more clear students, I will explain you with the help of the diagram. Now let's have a look on the diagram. So students, now here you can see the two containers. Okay. Now the first container and second container both are given as heat, but in the first container a fixed piston is put. Okay. The pressure or air cannot get outside of the piston. The piston is put it as fitly, and on the second container the piston is movable. Air or other things can move out. So what happens in the first case, only the burner is on, only the pressure will increase, but the volume will not increase. I'll give you an example for this. You know pressure cooker. What happens in the pressure cooker? Heat is given. It's on the gas. What happens over there? The lid of the cooker is fixed tightly. So volume inside does not increases. Only the pressure gets increases, and you can hear the whistle also of pressure cooker. And in the second case, the movable piston, here volume increases because it has a way to move. So in the second case, there is no fixed lid, no fixed piston, so volume increases. Okay students, I hope so this concept is clear to you. Gas expands on heating, but if the gas is kept closed, its volume cannot increase, but its pressure increase. Best example for this is a pressure cooker. Now students, the expansion of a gas is measured by keeping its pressure constant. This volumetric expansion coefficient is called the constant pressure expansion coefficient, and it is given by the following formula. Same how we did for areal expansion in solid. Now we learned expansion of liquid. We denoted the formula. Same how the formula of expansion of gases, V2 is equals to V1 multiplied by 1 plus beta into delta T. Here delta T is the change in the temperature, and V1 and V2 are the initial and final volumes of the gas at constant pressure. Beta is the constant pressure expansion coefficient of the gas. So students, it is all concepts are very clear to you all. Hope so you all have been understood. So students, this was all about lesson number 14, measurement and effects of heat. To get more clear, students, to get your concepts clear, please re-see the video repeatedly and with full attention to get all your concepts clear. Thank you so much students for your attention. Thank you so much. Have a nice day.